Okay, in this video, we're going to talk about naming ionic bonds. And I first want to tell you what an ionic bond is. Ionic bond happens when we have a metal combined with a nonmetal. These are called ionic bonds because they have a very strong connection between them, and because the metals they always want to give up their electrons and become positive, and nonmetals they always grab those electrons and become negative, and that makes them a really powerful bond, and that's why they called ionic bonds. And the ones who basically lose electrons and become positive, they are called cations. They are usually metals. And the ones who gain those electrons and become negative, they are called anions. Now we're starting with ionic bonds and naming ionic bonds because of the fact that they're really easy to name, and we have different ways of naming different bonds in chemistry, and ionic bond is one of the easiest ones, so I am going to start with this one. And the first example I have is sodium chloride or NaCl. Every single time you're trying to name something, try to look at what it's made up of. As you can see, the first element that we have is a metal, and the second one that we have is a non-metal. And this is very important that you know that the first one is metal and the second one is non-metal, or the opposite way, because as if these two were non-metals, that's a different way of naming, and that has its own rules. So first we're just going to talk about how to name these. So now that we identified that the first one is a metal and the second one is a non-metal, we know that we're going to use the naming for ionic bonds, which is a really easy one. When we're trying to name ionic bonds, the first cation or our metal should get its own name, which is just sodium. And I want to remind you that I'm bilingual and I might not be able to spell all of these correctly, but you know what I'm talking about because it's just a name. And yeah, the name for a metal doesn't change. However, for the non-metal or the anion, it's going to change, and we're going to put a IDE at the end of the name of the element. This is chlorine. However, when we're trying to write the name, because it's an ionic bond, it's going to become chloride. We're going to add this IDE at the end of the name of that element. Chlorine becomes chloride. Oxygen becomes oxide. And it goes like that, and it's really easy. Now again, for our next example, we have magnesium and nitrogen, and we have to figure out what the name of this compound is. Again, we first want to make sure that we have a metal and a non-metal. As you can see, magnesium is a metal and nitrogen is also a non-metal, which means using this method will be fine, and we are going to name it based on this. Now, something really important about ionic bonds is that we don't care about the subscripts that we see in the name. However, we do care about them when we have a transition metal, which we're going to talk about later in this video. However, since magnesium is just a metal and it's in the first two columns of our periodic table, we know that magnesium is a metal, and we're just going to use the basic way of naming ionic bonds. And we know it's magnesium, so magnesium. Again, we're going to change the name of the second element, or anion, which is nitrogen, and we're just going to add that IDE at the end of the name, which is going to make it nitride. And now we have potassium and chlorine, and we need to make sure that the first one is a metal, which is potassium, and it is a metal. And then we have chlorine, which is a nonmetal, which means it's going to be an anion, and we have to add that IDE at the end of the name. So it's potassium chloride. For our next example, we have iron and chlorine. Now we have to figure out how to name this because the first thing that we have, or the first element that we have, is not a metal, it's a transition metal. It's a metal that is located in this side of our periodic table, and we need to figure out how to name it. And these are called transition metals because of the fact that they are in between metals and nonmetals, and we have a lot of transition metals that are here. However, the way that they're named is because of the fact that they do not have a perfect charge, or they don't have a charge that's stable. Their charge might change. That's why we're just gonna use this method to name them. And the way of naming them is really similar to the method that we introduced before. However, there's a slight change into how to write this. So first, we're just gonna write the name of the element, which is iron. Now, because the charge is something that's going to be changing in these, for these elements, we're just gonna write the charge of this element in Roman numeral. As you can see, because I gave you this shortcut, you should know that the charge for Fe, or iron, is +3. So we're just gonna write 3 in here. And then because chlorine is an anion, we have to add that IDE at the end. So it's going to become chloride. Iron 3 chloride, that's how you say it. Now this is the best example to show where the charge for iron, or Fe, is changing. As you can see, this time the charge is going to be +2. That's why it's really helpful when you have a transition metal that are located in the middle of the periodic table. It's really helpful for us to write down that Roman numeral and to show the charge of our element. Again, we know it's iron. However, the charge this time is +2, so we're just gonna put a 2 in here. And we know chlorine becomes chloride because it's an anion. And it's iron 2 chloride. This is the name of this compound. Now we have copper and oxygen. Again, we're just gonna ask ourselves, is this a metal or a transition metal? As you can see, copper is located somewhere in the middle of our periodic table, which means it should be a transition metal. And we're gonna use the same method that we used for the past two examples, which means I'm first going to write down the name of the element, which is copper, and then we're gonna look at the charge of copper. In this case, you can see that there's no subscript for oxygen, which means the subscript is 1, so the charge for copper should be +1. And for oxygen, because it's an anion, we're just gonna add that IDE at the end of the name. So it's copper 1 oxide. Now we can have copper and oxygen, and as you can see in here, there's no indication of any charge for copper, and we don't see any subscript for oxygen. How do we figure out the charge of copper? As I've been telling you how to figure this out, it's just x plus that -2 equal to 0. So we know it's x plus -2 equal to 0, and we just need to find x, which means x is equal to +2, which means the charge for copper in this case is +2. And if we're trying to write the name of this down, we're just going to write copper, and instead of the charge, we have to put the charge in Roman numeral, which is just 2, and again oxide. Now, to sum everything up, when you're trying to name an ionic bond, you have to make sure that you have a metal and a non-metal. After you figure that out, you have to look at the metal and see if it's a transition metal. If it's a transition metal, you're just going to write down the charge of that transition metal in the middle and then write down the anion. However, if it's just a metal, you're just going to write down the name of the metal and then the name of the anion or our non-metal with IDE at the end of the name. And that's it for this video, and I hope you do great. Thank you.